On a quiet night in Australia, a radio telescope caught something that should have been impossible. It lasted less than 1,000th of a second. Then it disappeared. No explosion, no warning. Just a single burst of radio energy, so powerful that, for an instant, it outshined entire galaxies. At first, it looked like another mysterious fast radio burst, one of the strangest signals ever detected in the universe. But when astronomers traced where it came from, everything changed. The signal had traveled nearly 8 billion light-years before reaching Earth. That meant it had begun its journey when the universe was almost half its current age. The question wasn't just what created it. The real mystery was, how could something so unbelievably powerful survive a journey across almost half the observable universe without fading away? Fast radio bursts, or FRBs, are among the greatest unsolved puzzles in modern astronomy. Each one lasts only milliseconds. Blink and it's gone. Yet during that tiny fraction of a second, an FRB can release as much energy as our sun produces over several days. Scientists have detected hundreds of these bursts. Some repeat, most never do. For years, researchers argued about their origins: colliding neutron stars, exploding magnetars, black holes, even theories involving completely unknown physics. But none of those explanations fit every observation. Then came one particular burst that pushed the mystery even further. In June 2022, the ASKEP radio telescope in Western Australia caught an incredibly bright flash. It was officially catalogued as FRB 2022-0610A. At first glance, it looked ordinary by FRB standards, but locating its source revealed something astonishing. Using some of the world's largest optical telescopes, astronomers searched the exact region of space where the burst had originated. They expected to find a nearby galaxy. Instead, they found a faint, ancient galaxy, so distant that its light had taken roughly 8 billion years to reach Earth. Nothing like this had ever been confirmed before. That discovery raised an even bigger question. If the signal had traveled that far, it hadn't simply crossed empty space. It had traveled through billions of light years filled with invisible matter, magnetic fields, and enormous cosmic structures. Every one of those regions should have weakened or distorted the signal. Yet somehow, it arrived with enough strength to be detected by instruments on Earth, almost as if the universe itself had carried it safely across unimaginable distances. Scientists realized the signal contained something even more valuable than its energy. It carried a record of everything it had traveled through. Like shining a flashlight through fog, the burst revealed tiny delays in different radio frequencies. Those delays exposed invisible clouds of matter scattered between galaxies, matter that had remained hidden for decades. Suddenly, one mysterious radio flash had become a tool for mapping parts of the universe that telescopes cannot normally see. But as researchers analyzed the data more carefully, another surprise emerged. The host galaxy didn't match expectations. Instead of a simple, quiet galaxy, it appeared far more complex than anyone predicted. Signs suggested a chaotic environment where stars were forming rapidly, galaxies may have interacted, and extreme magnetic conditions could exist. If that's true, then the object producing this burst may have lived inside one of the most violent neighborhoods in the early universe. And that changes everything scientists thought they knew about these signals. Because if this burst came from an environment unlike those of previously studied FRBs, then perhaps the true source isn't rare at all. Perhaps we've been looking in the wrong places. Or worse, we've misunderstood what fast radio bursts really are. And the next clue hidden inside this ancient signal may force astronomers to rewrite one of the biggest assumptions about the invisible universe. As astronomers continued studying FRB 20220610A, they realized this wasn't just another record-breaking detection. It was a cosmic measuring tape. For decades, scientists believed that a large portion of the universe's normal matter was missing. Not dark matter, ordinary matter made of protons and electrons. Computer models predicted it should exist, but telescopes couldn't find enough of it. Galaxies didn't contain it all. Stars didn't explain it. Even enormous clouds of gas came up short. The universe seemed to be hiding nearly half of its visible matter. Then this ancient radio burst crossed almost 8 billion light-years of space. Every cloud of thin gas along its path slowed different radio frequencies by tiny amounts. Those delays were incredibly small, but they added up over billions of years. By measuring that delay with extraordinary precision, astronomers could estimate how much otherwise invisible matter the signal had passed through. The result was remarkable. The missing matter wasn't missing after all. Much of it was spread across the vast emptiness between galaxies, so thin that ordinary telescopes could barely detect it. Yet the radio burst had revealed its presence simply by passing through it. A mystery that had puzzled cosmologists for years suddenly became much clearer because of a signal that lasted less than a millisecond. But solving one puzzle opened another. If a burst this distant could still be detected so clearly, its original source had to be unbelievably powerful. One leading suspect is a magnetar. A magnetar is an ultra-dense neutron star with the strongest magnetic fields known in the universe. When those magnetic fields suddenly rearrange, they can release enormous amounts of energy in an instant. Scientists have already linked some nearby fast radio bursts to magnetars, but FRB 20220610A may have come from a much younger universe where stars formed faster, galaxies collided more often, and extreme objects may have behaved differently than they do today. Could ancient magnetars have been even more energetic? Or are there multiple kinds of cosmic engines producing fast radio bursts? No one knows yet. Another clue lies in the burst's incredible brightness. To be visible across nearly 8 billion light-years, the signal either started with unimaginable power, or nature found a way to focus its energy into an exceptionally narrow beam, almost like a cosmic lighthouse sweeping across the universe. If Earth happened to cross that beam for less than a millisecond, we would see exactly what the telescopes recorded. Miss it by a fraction of a degree, and the event would remain completely invisible. That possibility suggests the universe may be producing far more fast radio bursts than we detect. We only see the rare ones aimed directly at us. Every new radio telescope is expanding that picture. With more sensitive instruments, astronomers are discovering bursts from greater distances and tracing them back to galaxies that existed billions of years ago. Each detection becomes another probe sent naturally through the cosmos, carrying information about regions humans could never visit. Instead of launching spacecraft across impossible distances, scientists can read the fingerprints left inside these ancient signals. That is what makes FRB 20220610A so extraordinary. It wasn't simply a mysterious flash. It became evidence that the universe itself can help us study its hidden structure. A single millisecond connected Earth to a galaxy whose light began traveling long before our planet even existed. It revealed invisible matter floating between galaxies. It challenged assumptions about where these bursts are born, and it hinted that the early universe may have been far more violent than we once imagined. Yet the biggest question remains unanswered. What actually creates the most powerful fast radio bursts? Magnetars remain the leading explanation, but they don't explain every observation. Some bursts repeat, others never return. Some come from young galaxies, while others appear linked to much older environments. The pattern is still incomplete. Every new discovery answers one question while creating several more. Perhaps that's why these signals continue to fascinate astronomers around the world. They remind us that even after centuries of studying the sky, the universe still speaks in ways we barely understand. Somewhere billions of light years away, another invisible flash may be already racing toward Earth. It has crossed galaxies, empty cosmic voids, and oceans of unseen matter for billions of years. Perhaps it's carrying the clue that finally explains fast radio bursts, or perhaps it will reveal an entirely new mystery that no one has imagined yet. Because in the universe, the most important message may arrive in less than a millisecond and change everything.